Hello and welcome. I'm your host and speaker, Sagar Nolaspore, and I'm Associate Data Engineer at Infometry. Thank you for taking the time to join us today. In today's webinar, I will be talking about metadata information for databases. Feel free to drop your questions on the topic or share your struggles and experience during the live session. We will answer your queries through chat. Let's start the session. This session is organized by Infometry. We are pure play data analytics company based out of Fremont, California, with our offshore development center in Bangalore, India. We came into inception back in 2010, and since then we have been offering domain-specific analytics solutions for high-tech, energy, life sciences, retail, manufacturing, and finance customers. Being a data analytics software service and solutions provider, we focus on delivering productive and prescriptive analytics solutions, cloud data warehouse implementation, data governance, enterprise service bus, microservice-based integration solutions, big data, cloud DevOps, Salesforce CRM, and product engineering, etc. Infometry has been an engineering and consulting services partner for companies like Informatica, Matillion, Snowflake, Tableau, Adaptive Insights, Looker, etc. Infometry offers domain-specific analytics solutions for high-tech energy, life sciences, retail, manufacturing, and finance customers. In addition to the services, we have also developed more than 15 cloud connectors for ISCS. One mentioned under blue blocks are developed and owned by us, and the rest are developed by us only. For organizations like Informatica, SAP, Caritas, etc. We have developed state-of-the-art analytics solution, InfoFiscus, which can be hooked to any on-prem or cloud CRM or ERP planning apps. InfoFiscus is 100% cloud-based, pre-built analytics software developed using open architecture. InfoFiscus comes in three different flavors: finance, supply chain, sales and marketing analytics. We are delighted to announce the launch of the next generation InfoFiscus Sales Analytics Snowflake native application, which aims to streamline the sales analytics for customers using Salesforce, Marketo, and Snowflake. That's our quick introduction, and now let's move on to our today's agenda. What is database? Database is a structured collection of data designed for efficient storage, retrieval, and management. Let's discuss the significance of metadata for database objects. Tables. Tables contains data in rows and columns. Views provide a virtual representation of data based on queries. Indexes speed up the data retrieval. Procedures automate complex workflows. Let's look at the query. Uh, Here I used a SQL Server as an example database where we will be fetching the queries. So let's look at the query. Query is used to retrieve details about database objects such as tables, views, store procedures, and functions to understand the overall structure of the database. Here, like we used sys.objects as a table which is inbuilt where the metadata information for all database objects will be stored. So let's look at the next. Let's move on to the schema, a critical part of the database metadata. Let's look at the next. What is schema? Schema is a logical grouping of database objects that helps organize and secure the data. The components of schema metadata. Let's a list of tables, views, procedures, and other objects. Let's look at the query, like how we can fetch the schema details from the table. In this, like we used in information schemata as a table. from where like we will be fetching the schema details from the database. So let's look at the next slide. What is column? Column is a single field in a table that stores specific data types. Let's look at why column data type and size is important. It ensures data consistency, helps developers and analysts understand data constraints. And here we have a query to fetch column data type and size. To fetch column data type and size, we select column name, data type, and character maximum length from a table called information schema dot columns. As you can see in the query, there we have given a table name which I used as a department. Once you execute the query, you will get the column name, data type, and size. As you can see in the output here, the department ID is of data type int and the size is null, which we have not given. So let's look at the uh, next slide is relationships like primary key and foreign key. What is primary key? Primary key is a unique identifier for each record in a table. This means that no two rows can have the same primary key value, ensuring that every entry is distinct. Additionally, primary key fields cannot contain null values, meaning every record must have valid identifier. Let's look at the query, how we can get metadata information about primary key. Our query's objective is to identify primary key in the database to understand table uniqueness constraints. In this query, as you can see, we are using sys.tables, sys.index, sys.index columns, and sys.columns to fetch table name, primary key, and column name. Once our query executes in the SQL server, the output will looks like this. The table name will be like departments, employee, project assignments, projects. These are the table names. The primary key name will be the system assigned. The PK department B20. These are the system assigned primary key name. And the column name is which the department ID, where this department ID is a primary key. That's how it is. What is foreign key? Look at the foreign key is a field or set of fields in one table that creates a link between records in two tables by referencing the primary key in other table. This establishes a relationship between the tables. It ensures that the data remains consistent and accurate. Let's look at how we can get metadata information about foreign key. By looking at the query, this query retrieves details of foreign key relationships to understand table dependencies and data integrity. Here we are selecting the foreign key name, primary table, reference table, column name, and a referenced column. Like the tables are like foreign sys.foreign key, sys.tables, and sys.foreign key columns, and sys.columns. As you can see, the foreign key name is the name of the foreign key constant, and primary table is table containing the foreign key, and a reference table is a table being referenced, and the column name in the primary key table forming the foreign key. Reference column is nothing but columns in the reference table. Once we execute this query, we'll get the foreign key name, primary table, reference table. Reference table is which we used in a primary key. The primary key table will be referenced here, the column name and the referenced column. Now let's look at the next slide, which is constraints. What are constraints? In relational database, constraints are rules applied to the table columns to ensure the accuracy, consistency, and integrity of the data. They define the valid data types, relationships, and conditions that must be met within the database. Implementing constraints helps maintain data reliability by preventing invalid data entry and enforcing business rules at the database level. Here are some common types of constraints. First one is not null constraint. It ensures that the column cannot have a null value, meaning every record must contain valid value in this field. Unique constraint. It ensures that all values in a column are distinct across the table, preventing duplicate entries in the specific column. As we have seen in the last slides, primary key, the combination of the not null and a unique constraint, it uniquely identifies each records in a table. Each table can have only one primary key, which may consist of a single column or a multiple columns. Foreign key constraint, it establishes a relationship between two tables by linking a column in one table to the primary key of another table. The check constraint, it specifies a condition that must be met for the data to be accepted into the column. The default one assigns a default value to a column when no value is specified during the data insertion. Let's look at the query, how we can get the constraint details from a database query. We will be selecting a table name which helps us, which is associated with the constraint. The constraint name is the name of the constraint, and the constraint type, a type of constraint, which is primary key, foreign key, unique, check, and a default. Column name, the column name involved in the constraint. Here we are selecting the from tables as a sys.objects, sys.tables, sys.columns. From this, we will be, once we execute this query, we will be getting the table name, constraint name, and the constraint type which the table contains, and the column name which the constraint type is assigned to. Now let's look at the next slide. What is stored procedure? In relational database, a stored procedure is a set of precompiled SQL statements that are stored under a name and are processed as a unit. These procedures are saved in the database and can be executed as needed, allowing for a code reuse and efficient database operations. There are some of the key features of stored procedures. Precompiled is execution. Stored procedures are compiled once and stored in an executable form, which can lead to quicker and more efficient execution. There is another one, parameterization. They can accept input parameters, allowing the same procedures to be used with the different data inputs. And encapsulation of business logic. The store procedures can encapsulate complex business logics within the database, promoting consistency and reusability across applications. Let's look at how we can get the store procedure metadata information from the database. Executing this query, We will be able to retrieve metadata about stored procedures, including their names and definitions for analysis and debugging. As you can see here in the select, they selected procedure name, routine type, and the definition. The procedure name is the name of the procedure. For the routine type, it should be it should always be a procedure. For the definition, it is the SQL code of the procedure. Once you execute it, you'll get the procedure name, and the routine type is always a procedure, and the definition is of the procedure SQL code, which is uh, stored in a definition. Let's look at the next slide. What is function? In SQL, function is a custom function created by users to perform a specific task within the database. Functions accept parameters, execute a series of SQL statements, and return a result, which can be either a single value or a table. They are useful for encapsulating complex calculations or operations that need to be reused across multiple queries. There are two types of functions. One is scalar and the second one is table valued function. For a scalar function, it returns a single value such as integer, decimal, or a string, which can be used wherever a single value is expected in SQL statements. For table valued function, it returns a table data type. It can be treated as a table in SQL queries, allowing for operations like joins. Let's look at the query. This query looks similar to as a procedure to fetch metadata information, where the column names are function name, routine type, and definition. Obviously, the routine type and definitions uh, are same only. Like for functions, it would be the routine type will be function, and the function name is the name of the function. Once you execute this, you will get the output as a function name, where it is the name of the function is returned, and the routine type is function, and definition you will get the SQL code for the your respective function. So let's look at the next slide. Conclusion. The integration of metadata management brings a transformative impact on organizational data practices. By streamlining data organization, it reduces complexity, enabling teams to focus on meaningful insights rather than administrative hurdles. Enhanced discovery ensures critical information is easily accessible, empowering informed decision making across departments. Effective governance safeguards compliance with regulations, mitigating risks, and fostering trust. With lineage tracking, transparency and traceability becomes inherent, strengthening accountability, reliable insights driven by accurate metadata elevate the confidence in decision-making processes. Moreover, shared metadata fosters collaboration, aligning team towards the common goals and ensuring consistency in execution. Finally, scalability ensures that as organizational needs evolve, the metadata framework adopts seamlessly, supporting growth and innovation. Together, these benefits highlights metadata management as a cornerstone for operational efficiency, strategic alignment, and long-term success. Thank you. I encourage you to explore metadata in your own databases. Feel free to ask questions or reach out for additional resources. Anyway, I will be giving the SQL queries which we have seen today in a description or a chat window. Hello guys, like if you have any questions you can ask.
Yeah, hi Sagar.
Yeah.
Yeah, my question is, how does metadata improve data governance and compliance in an organization?
Yes, like metadata helps track and manage data by providing details on where data comes from and how it is used and who can access it. And it also ensures rules and security that is followed, which is correctly or not. That's it.
Okay, thank you.
Yeah. Thanks. Anyone else?
Yeah, hi Sagar.
Yeah.
Yeah, can you please explain what are the different methods to retrieve metadata from Snowflake and SQL Server?
Yeah, sure, Ananya. See, in SQL Server, you can use like system views like information schema dot tables and sys objects is there. And for Snowflake, you can use like a show table, show columns, and there is also information schema in Snowflake. Yeah.
Okay, yeah.
For the next question, if you have any.
Hi Sagar,
Yeah. Yeah.
I have a question for you. Can you explain the role of schema metadata in organizing and securing database objects?
Yeah, see, a schema groups data type objects like say the tables and views, which will be making data easy to organize, and it also helps with security by allowing access control and at the schema level. Yeah,
Okay, sir. Thank you.
yeah.
Hi Sagar,
Hi,
why
Sanya.
and foreign key important data and how do they ensure
You were asking primary key and foreign keys importance, right? And for that, primary key ensures each record in the table is unique. And as for a foreign key, as you know, like it links
key
table
and
together. It links table together, and that ensures data accuracy and its consistency. And these primary key and foreign key both helps maintain databases integrity. That's what.
Yeah, hi Sagar.
Sagar? Thank you.
Hi there, Raj.
Yeah. Thank you so much for this amazing webinar on metadata. I hope everyone found the session really insightful and useful. And yeah, that's. Thank you for joining, everyone. Have a nice day. Thank
Yeah,
you so much. Yeah.
thanks, guys.
Yeah.
Bye.